Okay, so let's keep going, and we'll do 2, which is going to be the same thing, but just a little bit more of an interesting solution. So this was y double prime plus 9y equals 0. And again, let's guess our solution as y equals ae to the cx, and we'll add some undetermined constant b here, although sometimes you won't see this listed as a solution. And as before, if y is that, then that means that the first derivative is going to be ace to the cx, and the second derivative is going to be ac squared e to the cx. Alright, now let's plug in these 3 for our original equation. So plug into 2, and we're going to get, change some color just for plugging in, we're going to get ac squared e to the cx. There is no y prime, but there is 9y, so plus 9 times y is going to be a e to the cx plus b. Okay, and we know that this has to equal 0. And now I'm going to distribute the 9. Okay, this is kind of a trivial step, but I'm just doing it to be clear and make sure that I don't make any silly mistakes along the way. Plus 9ae to the cx plus 9b equals to 0. Okay, and so we can see right away, actually, that because this term has an e in front of it, and this or at the end, and this term has an e at the end, and this term is kind of all by itself, you can kind of see right away that b has to equal 0 here. So we can see from this, b has to equal 0. And so I'm actually just going to go right ahead and say, and get rid of b right here. So b equals 0. So we can see straight away that b equals 0, and we're just going to stop considering it from here on out. So now let's rewrite with b equals to 0. And you'll have ac squared e to the cx plus 9a e to the cx equals 0. And we'll do, I'm just going to combine it into all the past steps into one here and say cancel the a and the e to the cx, since not equal to 0. Since if it were, you'd end up with this sort of situation where y is at most a constant, and your differential equation is what's called trivial, because nothing is happening. So now you'd be left with the a's are gone and the e's are gone. So c squared plus 9 equals 0. And now rearrange. And we get c squared equals negative 9. And now we're going to solve for c. And that means take the square root on both sides. And so we can see actually that c is going to be a complex number. It's going to either be plus 3i or it's going to be minus 3i. So I'm just going to shift over a little bit. So that's our value for c. And now we're going to plug into y. And something kind of interesting will happen, so let's see what happens when we plug into y. So I'm going to go to top of page here. Top of page. Okay, so go up here. Okay, so we have y equals a e to the cx, where c is either going to be ae to the 3ix or ae to the minus 3ix. Okay, and well, why don't we plug in and see what happens? So let's consider both cases, plug into 2, and see what happens. So we're going to call this, just need to move over a little bit. We're going to call this case A, we're going to call this case B. So, and we're going to plug it into A. Let's start with A, which is where y equals ae to the 3ix. And then that would mean that y prime is going to equal a times 3I times e, sorry about that, e to the 3ix. And that means that y double prime is going to be a times 3I squared e to the 3ix. And as a side note, e to the, 3I squared is going to be 3 squared times I squared. And I squared is going to be minus 1, and 3 squared is 9. So this is minus 9 equals a to the minus times minus 9 times e to the 3ix. So now equation 2 is just going to be, again, it's going to be y double prime plus 9y equals 0. It's equation 2 that we're trying to solve. So here's y double prime, and here's y. So if we plug it in, we get a times minus 9 times e to the 3ix plus 9 times a times 3 times e to the 3ix. That has to equal 0, and we can see that this is going to be 9 e to the 3ix plus 9 a e to the 3ix, and that's going to equal 0, and we can see indeed these cancel. Great. Okay, so we know that A works as a solution. Well, what about B? Well, let's do B real quick. We're going to have y is going to be ae to the minus 3ix. Y prime is going to be minus 3I times ae to the minus 3ix. Y double prime is going to be minus 3I squared times ae to the minus 3ix. And again, side note, let's see, minus 3I squared is going to be minus 1 squared times 3 squared times I squared, and this is going to be minus 1 squared is 1, 3 squared is 9, and I squared is minus 1, so this is going to be minus 9. So that means that y double prime is going to be minus 9 times ae to the minus 3ix. So now let's plug this into 2. And we're going to get y double prime, which is minus 9ae to the minus 3ix. And we're going to get plus, the rest of the equation is plus 9y, and y here is ae to the minus 3ix. And that has to equal 0, and we can see again right away that this and this cancel, so it does indeed equal 0. So it's equal 0. So we're good here. And so, okay, so we can see that they're both solutions. So since they're both solutions, what do we do? Which one is the right one? And well, the answer is there isn't a right one, and I believe it's called the superposition principle for differential equations, where if A is a solution and B is a solution, then A plus B, I'll write it out. If y equals A is a solution and y equals B is a solution, then A plus B is also a solution. And we can show that. This is a little bit of a tedious thing to do, but it's good to do just once. So why don't we check this by saying, why don't we say y equals a e to the 3ix, and then I'll do a different color here just for cleanness, plus, I don't want to say a here again because it doesn't really have to be the same constant, so let's just say plus d e to the minus 3ix. Well, let's take derivatives. So I guess I'm a little biased towards green here, but the derivative of y is going to be 3I times a times e to the 3ix plus the derivative of this with respect to x is going to be minus 3I times d. Again, d is just a number, just like a is just a number. And then the second derivative is going to be 3I squared a to the 3ix plus minus 3I squared d e to the minus 3ix. And I'm going to rewrite this with what we know from our two side notes is that 3I squared is going to be minus 9 a e to the 3ix. And also actually minus 3I squared is going to be minus 9 d e to the minus 3ix. So now let's plug into 2, our original equation. And which again I'm going to write, just to remind us, is going to be y double prime plus 9y equals 0. So our y prime, our y double prime is going to be minus 9 times a e to the 3ix minus 9 times d e to the minus 3ix. I'm just reading from this line here. And then we're going to do plus 9 times, I'm reading from this line here, a times e to the 3ix plus de to the minus 3ix. Okay, and that has to equal this, which has to equal 0. This has to equal 0. And so we can see, I'm just going to distribute the 9 here. So we get a 9 here, and we get a 9 here. And we see that individually you get this and this cancel, and this and this cancel, and thus the left side equals 0, which is what we need it to be. And so this is where you get the idea of kind of superposition of solutions. Okay, so then we're almost done, and the final answer is that y is going to be a plus b, and explicitly that's going to be y is going to be a times e to the 3ix plus some other constant times e to the minus 3ix. Now, there's actually one thing left to do, which is just as we went through with a plus b being a solution, you could also have a minus b be a solution. So it's actually plus, erase this here to give myself some more room. This is actually plus or minus. Plus or minus. And the last thing is, if we go way back over here, we have the relation between cosine and sine. So here, we have a relation between exponentials and cosine and sine. So I'm going to bring this knowledge over here, if my whiteboard will let me. And let's be a little difficult, but that's okay. And we can see that this is, if it's e to the 3ix plus e to the minus 3ix, this is actually cosine of 3x. And I'm going to divide by 2 here, which is equivalent to dividing by 2 here and dividing by 2 here, and setting a equal to d. Or if you had this solution, this is going to equal sine of 3x if you divide by 2i, which you could do if you let and divide by 2i. Which you can do because there's no constraints on what a and d are, so you can choose them to be whatever you like. Okay, so that means that this is a solution, and also this is a solution, and so again, from this principle here, which I'll circle a little nicer, we get that y equals cosine of 3x plus sine of 3x is our solution, and we need to have some unspecified constants here, and I'm going to reuse constants, but let's just say a and b. Okay, so this should be the solution to 2. And we're going to check one more time. So let's check one more time, just to convince you that this is, in fact, the way that things work out. So again, our equation 2 was the second derivative plus 9y equals 0. And so if we have y is going to equal a cosine 3x plus b sine of 3x, then let's calculate what y prime and y double prime are. Well, the derivative of cosine is going to be minus 3a sine of 3x, and the derivative of sine is a little bit nicer than cosine because you don't have the minus sign, is going to be 3b cosine 3x. And to get the second derivative, we just do the same thing again. So this is going to be minus 3 times 3 is minus 9, a cosine of 3x. And the cosine is going to flip signs, so it's going to be minus 3 times 3 is 9, b sine of 3x. Alright, and now let's plug it into b. Plug it into 2, equation 2. And we're going to get y double prime, which is this equation here. So that's going to be minus 9a cosine of 3x minus 9b sine of 3x. And the second part of the differential equation is plus 9y. So we're going to do plus 9 times y, which is y is here, plus 9 times a cosine of 3x plus b sine of 3x. And the last part of the differential equation is that this should equal 0. And so again, let's distribute the 9. So we're going to get 9a cosine 3x plus 9b sine 3x. And we can see, similar to how we're working things out with the exponentials, that this and this cancel, and this cancel, so this indeed is 0, which is what we need on the right-hand side, showing that this is the solution to 2.